Hi friends, first of all, thanks for being here. Now, today in this video, I explain the rank of a matrix by normal form or canonical form. So please subscribe my channel. In the previous video, I explained the echelon form of a matrix. I explained the echelon form of a matrix and how to be performing the row operations and column operations on a matrix. In this video, I explained normal form or canonical form of a matrix. First of all, define normal form or canonical form of a matrix. How do we define that? So every m by n matrix, every m by n matrix can be reduced into any one of the following standard normal forms. This is the first standard normal form. This is the second normal form. This is the third normal form. This is the fourth standard normal forms. Every m by n matrix can be reduced into these following normal forms. How to reduce it? So by applying a finite number of elementary row operations or column operations are both are both row operations and column operations are both. So in the standard normal forms we observe that IR is exist, where what is IR is the identity matrix of order R. Identity matrix of order R. Once the given matrix is reduced into normal form, then the rank of the given matrix, the rank of the matrix is equal to the order of the identity matrix in normal form. Okay, so these are the various normal forms. This is the example of first normal form. This is the example of third normal form. This is the example of fourth normal form. This theory is explained through examples. The first example, reduce the following matrix. So reducing this matrix into normal form, and hence determine its rank. Okay, so this is the matrix of order 3 by 3. So therefore rank of A less than or equal to 3. Suppose rank is 3, then the possible normal form as I3. Suppose the rank is 2, the possible normal form as I2 0 0 0. So that can be shown in the problem. So this is the I2, this is the 0 matrix, this is the 0 matrix, this is the 0 matrix. Okay, so first of all we applying the operations and reduce the given matrix into normal forms. Suppose the rank is I3, so to make this element as 0 and this element as 0, at the same time we make this element as 0 and the element as 0. So first of all we apply the column R2. So R2 tends to R2 means 3, 3 minus 3 into 1. Okay, 3 into 3 minus 1. So that is we get 0. So 4 minus 3 into 2, 6. 4 minus 6 minus 2. So 5 minus 3 into 3, 9. 5 minus 9 minus 4. In the same way, R3 tends to R3 minus 6 R1. R3 tends to R3 minus 6 R1. So R3 means 6. 6 minus 6 into 1. So we get 0. So 8 minus 6 into 2. 8 minus 12 minus 4. So 10 minus 6 into 3, 18. 10 minus 18 minus 8. Okay. So 3 and 6 make as 0. Now we make 2 and 3 as 0. We try to make these elements as 0. This is located in column 2 and column 3. So now we're performing the operations on column 2. So C2 tends to C2 minus and a 2, C2 means 2. 2 minus 2 into C1. So that make 0. In the same way, 3 is located in column 3. So C3 tends to C3 minus 3 into C1. So that make as 0. The remaining elements are not affected. Now, now this is minus 2. We make this element as 1. So for that we have to apply, this is located in R2, R2. So R2 tends to R2 by minus 2. So we get 1 and 2. So operations are applied only in R2. So only elements in R2 is affected. The remaining rows, remaining elements in the rows are not affected. Now we make this element as 0. So R3 tends to R3 plus 4R2. R3 tends to R3 plus 4R2. So minus 4 plus 4 is 0. So minus 8 plus 4 into 2, 0. Now our aim is to make this element as 0. So see, this is located in C3, C3. So C3 tends to, so C3 minus C3 tends to C3 minus 2C, 2C2. So that make that element as 0. So now this is I2. This is the 0 matrix of 1 by 2. This is a 0 matrix of 1 by 2. This is 0 matrix of 1 by 1. This is the 0 matrix of 2 by 1. This is 2 by 2. I2 0 0 0. So this is the normal form. Here order of the identity matrix is 2. So therefore rank of A equal to 2. Rank of A equal to 2. Okay. So we go to the next slide. So now reduce this matrix into normal form. So this is 3 by 5. This is the matrix of order 3 by 5. So therefore rank of A less than or equal to minimum of 3 comma 5. So that is minimum means 3. So rank of A is less than or equal to 3. So 3, suppose the rank is 3, then we get the normal form as, we get the normal form as, we get the normal form as I3 0 0. So I3 0 0. So that means I3 0 0 means that is I3, the remaining all as 0. Suppose the rank is I2, I2, suppose the rank is 2, so the possible standard normal form is I2 0 0. So that is I2 0 0 means, so I2 0 0 means that may, that is I2, this is the I2, this is the 0 matrix, this is the 0 matrix, this is the 0 matrix. So that will be see the apply after applying the operations. So first of all, this element make as a 1. So for this we have to interchange these two rows. R2 tends to R1 tends to R1 double implied by R2. So 1 1 2 3 5. Next, the second row is replaced by first row 3 to 5 7 12. The third row is remaining still at remaining exist. Okay. So now R2 tends to, so to make this element as 0, and next we try to make these elements as 0. So 3 minus 3 into 1. So R2 tends to R2 minus 3R1. R3 tends to R3 minus 3R1 that replaced in R3. So first element is, first row is not affected. In the second row 3 minus 3 into 1 0. So 2 minus 3 into 1, 2 minus 3 minus 1. So 5 minus 2 into 2, 4. 5 minus 5 minus 3 into 2, 5 minus 6, that is minus 1. So 7 minus 3 into 3, 9. 7 minus 9 minus 2. 12 minus 3 into 5 minus 15. So 12 minus 15 means minus 3. Next, 3 minus 3, 0. 3 minus 3, 0. 3 minus 3, 0. 6 minus 3 into 2, 0. Next, 9 minus 3 into 3, 9. 9 minus 9, 0. Okay. Next, 15 minus 3 into 15, 0. Okay. Now, we try to make these elements as 0. 1, 0, 2, 0, 3, 0, and 4, 0. All the elements are located in column 2, column 3, column 4, column 5. Now, so we make these elements as 0. We have to apply the column operations. So C2 tends to C2 minus C1. So 1 minus 1, 0. Next, C3 tends to C3 minus 2 into C1. So that is 0. Next, C4 tends to C4, 3 minus 3 into C1. So that element has 0. Next, 5 minus 5 into C1. So that element has 0. So that can be written in. So the remaining elements are not affected. So R2 tends to, next we make this element as 0. Now we make this element as plus 1. Plus 1. So we apply R2 tends to minus R2. So R2 tends to minus R2. So first row and third row is not affected. The second row, the all minus numbers are converted into positives. So 1, 1, 2, 3. Now we have to apply, we make this element as 0 and we make this element as 0 and we make this element as 0. So for this is located in column 3, column 4 and column 5. So column 3, C3 tends to C3 minus C2. C3 tends to C3 minus C2. Next, C4 tends to C4 minus 2C2. C5 tends to C5 minus 3C2. So we get 1, 0, 0, 1. All the elements are 0 in the column 2. 1, 2, 3 make as 0. Now, this is the I2. This is the 0 matrix of 2 by 3. This is the 0 matrix of 1 by 2. 1 row, 2 columns. This is the 0 matrix of 1 by 3. 1 row, 3 columns. So that is the normal form. So in this normal form, the order of the identity matrix is 2. So therefore, rank of the matrix equal to 2. Once the matrix is reduced into normal form, then rank is equal to the order of the identity matrix. Next question. This is a given matrix. Here, the order of the identity matrix is 3 by 4. So rank of A less than or equal to minimum of 3 comma 4, that is less than or equal to 3. So once the rank is 3, that is I3 0. This is one of the standard normal form. Suppose the rank is 2, that is I2, the remaining all 0, 0. This is one of the normal. So the given matrix is reduced into either this form or this form. So that will be seen in future. So first of all, we have to apply the operations. So to make this element as 0, this element as 0. So this is R2 row, this is the R3 row. So kabatti R2 tends to R2 minus R1, 1 minus 1, 0, 2 minus 2, 0, 3 minus 3, 0, 4 minus 2, 2. Next, 2 minus 2 into 1. So R3 tends to R3 minus 2R1, that is located in R3. So 1, 2 minus 2 into 1, 0. 6 minus 2 into 2, 4. 6 minus 4, 2. 7 minus 2 into 3. 7 minus 6, that is 1. So 5 minus 2 into 2. 5 minus 4, that is 1. Okay. Next, we try to make 2 as 0, 3 as 0, 2 as 0. So this is C2, this is C3, this is C4. So C2 tends to C2 minus 2C1, C3 tends to C3 minus 3C1, C4 tends to C4 minus 2C1. So 2 becomes 0, 3 becomes 0, 2 becomes 0 in the C2, C3, C4 columns. So the remaining all elements are not affected. Now to make this element as 1. So for that we have to interchange these two rows. So R2 implies R3. So the first row is not affected. The second row and third rows are interchanged. So we get 1 0 0 1 0 0 0. So next 0 2 1 1 0 0 2. So now to make now to make these element as 1. So these columns are interchanged. C2 implies and implied by C3. So C2 implies and implied by C3. So 1 0 0 0 1 0 0 0 1 0 0 2 0. C2 and C3 are replaced and C4 column is same. We write the same order. So now we make this element as 0 and this element as 0. This is located in C3 and this is located in C4. So C3 tends to C3 minus 2 into C2. In the same way, C4 tends to C4 minus C2. So the 2 and 1 becomes 0, 0. The remaining elements are not affected. Now R3 tends to R3 by 2, that make as a 1. So now we interchange these rows C3 and these columns C3 column and C4 columns are interchanged. So 1 0 0 0 1 0. So 0 0 1 0. So this is what identity matrix of order 3. This is the 0 matrix I3 comma 0. This is one of the normal form. So in this normal form, the order of the identity matrix is 3. So therefore rank of A equal to 3. Okay, so these are the way to reduce the given matrix into normal form or canonical form and hence find its rank. This is the procedure for solving or reducing the matrix into normal form. Here the most important thing is to apply the elementary row operations or column operations. Once we perfect in these operations, okay, so now we do the problems are very easy. Okay, so thanks for watching this video. So please subscribe and like and share the videos. Thank you, friends.